Hi guys, this is Madeline. I hope y'all had a wonderful day today. I'm so glad that y'all are at today's meeting. So this is lesson 2 of our science fair video series. So week 2, lesson 2. Today what we're going to be going over is experimental design. I apologize if there's a little bit of tapping in the video. It's because I'm using my pencil and I'm still trying to get the iPad set up all figured out, but we'll get there eventually. While I'm talking in the video, please be sure to pause anytime key vocabulary come up or anytime it's a good point of discussion within the meeting to just clarify, answer any questions, and then go over some examples from previous projects of what this term might mean, what that term might mean. At the end of our video, my expectation is for all of you to go and practice these terms that we've explained all together and write down what you think an independent variable means, a dependent variable means, a variable, a controlled variable, a hypothesis, and then constraints and criteria in your own words in the Google Doc that we've been working in. And then while you're writing that down, think about how these might apply to your project, and that'll kind of get you started on designing your experiment. The biggest thing that is basically due before the next meeting, we need to go ahead and decide whether we're going to do an experiment project or an experimental design, also known as engineering project. So today, the idea is that we've already spent last meeting going over what our topics are going to be, and we all have specific topics that are testing something, that are real world, that we have in our minds. We have them written down in our Google Doc, and basically what we're going to do at this meeting is either develop that idea into a hypothesis testing experiment, or we are going to develop that idea into an engineering goal research project. So both sides of that are a little bit different. Either you're going to be going through the steps of the scientific method or the steps of the engineering design process. And so that's what today's video is going to be explaining, kind of the difference of what that is. And then we're going to go over some basic vocabulary that all science fair students should know. If you're a returning member, these will probably be a refresher and you might already know these. But every year it's very important to go over these because not only are these vocabulary a big part of science fair, but these key concepts are a big part of all research in general, and scientists use things like variables and all the new information we're going to cover in this video in order to create their professional research projects, and that's simply just how science is done. So before we get right into that and what we're going to do with our projects, I just wanted to show y'all, give y'all a little bit of an example of kind of where we're going and like the grand scheme of things, the order. I'm going to try to get this keyboard to go away. So this is a board that I made previously in one of the years past. If you can see at the top is our title. We'll get there to where we're making our titles. But we always start on the top left where it says problem and question, and then we go on to hypothesis, variables, then we do lots of research. We then make our materials and procedures, we design our experiment, and then eventually we get onto the next page where we have our conclusion, we have our graphs, tables, and charts, our data analysis, and then finally our works cited. So that's kind of how it goes. Today we're going to start in the very top left corner with our very first step, creating our problem and question, and identifying some variables, kind of going over what all that general terminology means. For those of us, if it's your first year doing science fair, this might kind of be like a heavy video, so always you can go back and rewatch it and just try to understand as we go along. So I'm going to read to you the experimental design part. When you pursue an experimental or variable testing project, you begin by asking a clear and testable question about how one factor might influence another. So we have our topics, and so we kind of have a clear and testable question, but today what we're going to get to is about how one factor might influence another. So after completing some background research to understand what is already known, like we did at the last meeting and in our Google Doc, you form a hypothesis, which is a prediction about what will happen and why. Next, you identify your variables: the independent variable, the factor you intentionally change, the dependent variable, the factor that you measure or observe, and the controlled variables, the factors you keep the same to ensure fairness. Once these are defined, you design and conduct your experiment by writing a step-by-step procedure, performing several trials, and collecting data in an organized way. After completing the experiment, you analyze your results using tools such as graphs, tables, or averages to identify patterns and relationships. From this analysis, you will draw a conclusion by comparing your results to your hypothesis, your original hypothesis, explaining what your data shows, and discussing any possible sources of error or ideas for future testing, any discrepancies. Throughout this process, your focus is going to be on accuracy, control, and objectivity so that your results remain valid and reliable. So we're not going into this with any bias, and we're not really betting or expecting on any results. You have to go into science kind of with an open mind. Okay, so experimental design key concepts. In an engineering project, the goal is to create or improve something that provides a solution to a real world problem. We already have that part down. We've picked our real world problem, and we're going to get to our solution. The process begins when you define the problem or need you want to address, and then gather background research on how similar challenges have been solved. You then establish your criteria, which are specific requirements that your solution must meet, and your constraints, which are limits involving factors such as cost, materials, size, time, or safety. After that, you brainstorm possible ideas, sketch or model different solutions, and select the option that seems most effective. You build a prototype, a preliminary working version of your design, and test it to determine how well it meets the established criteria. Testing helps you identify which parts of the design work well and which areas need improvement. Using what you learn, you redesign and refine your solution, moving through multiple cycles of building and testing and improving until your design performs as efficiently and effectively as possible. The engineering design process is an ongoing and creative cycle that depends on persistence, careful testing, and constant improvement. So basically, you have to set some goals that your design is going to meet in order to define what is a successful experimental design. Basically, what is a successful prototype, and then what is not successful, what needs improvement. So now that we've identified your testable science fair project idea and you can determine which testing category your project falls into, you have finished the first step of this project. And now we can move on to identifying variables, criteria, and constraints to prepare for the experiment. So basically what we've just done is we've set up two different pathways that your experiment can follow. Pathway one, here, let me write right here. So in pathway 1 versus pathway 2. In pathway 1, that's where you test different variables. It's called hypothesis testing. When you do an experiment in order to see what happens and see if you can answer your question, basically, where you test multiple things, you compare multiple things. That's one way to go about it. That is the experiment route. And then the second way that we can kind of go about this is by creating some product or some design, whether that's an app, whether you're building a machine, whether you're building some code, whether you're refining some kind of like object that's already out there. Like if you were, for example, remaking a toaster, then you could also, instead of just testing an experiment on like how the toaster works, if you wanted to actually go and redesign it, a secondary option for you is doing the experimental design or engineering project route. So basically, what you're going to take this time to think about and choose is whether or not you want to just test things to get information. Like you could be comparing different watering schedules for different plants. You could be comparing the way mold grows on different types of breads. You could do all kinds of things, comparing or trying to bring in information using an experiment, or you could actually make something and kind of document the building process. You'll say, I'm going to make a toaster that is that uses 10 times less energy and that toasts bread 10 times faster. So you've set yourself some goals. 10 times less energy, 10 times faster. And so you're going to evaluate your design, whatever it is that you make, and see if you can meet those goals, and by that definition, achieve success or not achieve success and have to keep working on your prototype. So those are our two paths forward. So I encourage you to think about what specific idea that you came up with last meeting and see which sort of branch best fits your potential project idea. Okay, so that kind of concludes the whole brainstorming chapter. Now we're going to move on to the first major part of your project, which is asking your question and actually writing your research question, your official research question. We're going to write it down. And so we're going to go over some key terms, key vocabulary that I think are very important to know before you make an official research question, because it's important to understand the research design process as a whole before you get into the more complicated stuff like writing your own research design process and writing your own questions. Okay, so, didn't mean to write there. So today what we're going to go over, like I said, some key vocabulary. Highlighter. We're going to go over some key vocabulary terms. So the independent variable, that is the factor that you intentionally change in an experiment to test its effect. It's the cause part of a cause and effect relationship, and on a graph, the independent variable is plotted on the x-axis. So if you've taken a math class before and you've seen a graph, the x-axis is this axis right here. This is the x. And that's where your independent variable goes. So just to give you an example, it's the factor that you intentionally change it. So for example, if you watered plants on multiple different schedules, your independent variable would be each different schedule that you're using. So if you're only watering them in the morning, then for the independent variable, you would separate your plants into groups, and the type of watering schedule that each group received, that would be the independent variable, because that's the thing that you're changing. You're changing how often the plants get watered. And the reason why that's the independent variable is because depending on how often or when the plants get watered, that's going to impact directly the growth of each plant compared against each other. And that's how you're going to determine which plant had the best growth, which plant had the worst growth. So because of your changing of the watering schedule, you're going to have this desired result or undesired result with the growth of the plant. So that leads us directly into the dependent variable. That's the factor that you measure or observe in an experiment. It changes in response to the independent variable, and it represents the effect. And it's plotted on the y-axis. So that's the vertical axis right here. This is the y-axis. So like I said, in this plant situation, depending on the factors that you change about the plant's environment or how often you water it, the dependent variable is how well the plant grows because of your changes. And so you see how the dependent variable is, like in the name, dependent on the independent variable. All right, so at the meeting, I want you to quickly pause the video, and for those of us who have done science fair before, maybe you've had projects before, our student leaders, please go over and give a couple more examples using your project and other projects in past years about what the independent variable and what the dependent variable is, and people practice making up scenarios and try to create a few dependent and independent variables just to make sure that you understand what both of those concepts kind of are. And if you have any questions, as always, please ask. Okay. Let's move on. Now that we've gone over the two variables, those are the big main vocabulary terms. Just defining a variable, to give you a little bit more context, a variable is any factor, condition, or part of an experiment that can change or be changed. Variables can be independent, dependent, or controlled. So you can change it. If you can change it, then that means it's the independent variable. And if it's basically going to be changed depending on what you change, what the independent variable does, that's going to be the dependent variable. And then also controlled variables. That leads us right into our next vocabulary term. So a controlled variable is a variable that stays the same throughout the experiment so that it does not influence the results. And keeping these constant is how we ensure that the test is fair. So in an experiment, like I said, when we're changing things, when we're changing our independent variable, we're evaluating what result that change is going to cause. So going back to the plants example, I'm using it because it's very simple. For example, if we water different groups of plants, one group of plants we will only water in the morning, one group of plants we will only water in the afternoon, and one group of plants we will only water at night. So those are three different variables. We're going to measure the growth of the plants afterward, but a lot of times in science, we have to ask kind of difficult questions to make sure that what we are testing really truly is giving us the correct results. So for example, if we had this watering schedule, right? And then we placed one of the plants in the sun, but the other two plants happened to be inside at room temperature and they weren't getting any sunlight. Do you think that that might impact the way that the plants grow? I think it would. I think that the plants that are inside probably wouldn't grow as well. But does that have anything to do with the watering schedule that we're testing? Honestly, it doesn't. So that's why it's very important that we have controlled variables. We want to control all the other potential factors that could be changing in our experiment to isolate and make sure that we're only testing one so that we can be sure that the watering schedules are what's actually determining or causing these changes in plant growth. So this is how we ensure that our experiments are credible. And as you get into sort of professional science, you have things like control chambers, you do experiments in a vacuum. That's why we sanitize everything so well. It's to ensure that there is nothing that's being contaminated. There are no sort of outside disturbances that are introducing new variables or new factors into the experiment that we haven't already accounted for. So that's kind of the overall definition of a controlled variable. In science fair, there's also another thing called a control test that often, basically all of our projects have to have some kind of control test. It serves as a baseline comparison. So back to our plant example, we said we had a watering schedule of morning, afternoon, and evening. In addition to that, we should add a watering schedule where the plant does not receive any water, because there may be something that has to do with the water that is causing some kind of variation to happen, that if the plant doesn't receive any water at all, likely it's not going to grow a lot. But we need to be able to prove that so we can compare the ones that were watered in the morning versus the ones that were watered in the afternoon. We need to have something to compare them to. So the control would be the standardized one. There's nothing being done to it. No factors are being changed. It's just a plant that's not being watered at all. So we can make sure that watering it itself is not really going to have the huge impact, and that actually what we're looking through, the results that we're seeing, are because it was being watered at a specific time rather than being watered at all. And so when we make these comparisons, it also kind of shows us like how significant of an impact each variable has on our experiment. So I think watering in that scenario with plants, watering a plant is going to have a significant impact on the growth. But in other scenarios, for example, like if we were doing a drug trial or if we were testing medications, sometimes when medications are made, the medications actually don't do anything and they don't work. So we have to compare the results that we're collecting between patients not only that have taken the multiple different medicines we're testing, but also patients that have not taken any medications. So basically that is what a control test group is. It's just a group that has no treatment. It has absolutely nothing that's being adjusted, no factors, and we're just looking for baseline data so that we have something to compare our testing groups to. And so that's, in the same sense, it's another way of controlling your experiment and making sure that we are isolating the factor that we are testing. So those are kind of big terms. Those are the three big ones, the variables that we have to go over. The next thing is a hypothesis. A hypothesis is an if-then statement with a testable prediction that explains what you think will happen to the dependent variable when the independent variable is manipulated, and then why. So if I ask you what a hypothesis is, a lot of times the answer I get is a hypothesis is an educated guess. And while that is not necessarily wrong, in science fair, we like to quantify that a little bit more, and we refer to a hypothesis, as an if-then statement. The way that it is basically phrased and formatted, we say if, and then we list the independent variable, then we're going to list our expected impact on the dependent variable. So that's very important. I'll give you an example with the plants. If I water the plants on a morning-only watering schedule, then we expect the plant to grow the best, or to grow the tallest and have the biggest difference between the control variable compared to the afternoon and evening watering or evening plant watering schedules. So do you see how we're clearly comparing that if we change the independent variable in this particular way, then we believe the plant will grow the tallest or the highest in centimeters. It's very important that you include units and all kinds of things, those very specific details of exactly how you're changing the independent variable, what that testing group is going to look like. So sometimes our hypothesis, if you want to see an example, let's wait 1 second for the page to load. But a lot of times you can see my hypothesis. That is it's a chunky sentence. And a lot of our sentences, our problem, our hypothesis, they're going to be chunky sentences. So kind of don't shy away from that. We're going to have some example hypotheses coming up, but I just want you guys to pause the video at the meeting and then discuss a little bit about what different hypotheses could be, come up with some fake scenarios, fake projects, and make a few hypotheses, and each person practice doing it so that way it makes sense. And if you have any questions, please go ahead and ask and let me know. All right. Now we're going to move on to our next two big key terms. So the hypothesis, that is in the not the experimental design steps, but in the experiment testing sort of branch of doing a science fair project. Do you remember how up above on this page we talked about you can either do an experiment or you can do an experimental design or engineering project? So a hypothesis applies in an experiment. Before you actually do the experiment, you come up with an educated guess, that if-then statement, to basically see what you think is going to happen and then do research about why. And then later on in the experiment, you can prove if you were correct or not. But on the other side, kind of fork in the road, for the engineering projects, what students do is they evaluate criteria and constraints. So we kind of went over this earlier, but I'm going to go over the definitions one more time. Criteria are the standards or requirements a design must meet to be considered successful. They describe what the solution should be able to do or achieve. These goals quantify a successful versus unsuccessful prototype. Quantify means they make it measurable. By setting specific standards that your design or whatever it is that you make, by setting standards and goals that your design must meet, you're basically saying, you're giving yourself conditions to determine what is a successful design and what is an unsuccessful prototype. Okay, so then constraints, you also write these down. These are the limits or restrictions placed on an engineering design, such as available materials, size, cost, time, or safety requirements. In other words, your constraints are what is stopping you from meeting your criteria. So your criteria, previously I used the example of a toaster, and I'll just stick with that. We said our criteria is that we had to be 10 times more efficient. So we had to use 10 times less energy. And then we also had to be 10 times faster. Well, a set of constraints for that toaster project, we could say that part of our design is incorporating a cost-effective model. we can't expect families to buy a $250,000 toaster, right? That's very expensive. So we have to say, for this advanced toaster, we have to keep the costs under $50. We could also say that we want all of our toaster plastic to be made of recycled material. So these are big constraints, and this is specifically for a toaster project. But for example, if we were designing a drug, part of our constraints could be we need to make sure that people who have diabetes, people who have hypertension are still able to take this medication without it interfering with their normal medication or with their chronic illness. So you can see how these, like in the process of designing or engineering a new solution or like a new product, there are a lot of these criteria and constraints are very important. There's a lot of weight placed on these because they really could be legitimately life and death. That's what makes an innovation revolutionary versus what makes an innovation not useful. So we have successfully gone over a bunch of those really big, hefty vocabulary words. And next meeting, we're going to start off with an example just to give us a refresher of the experimental design process and of the regular problem question template. And so we're going to go over that, and next meeting you will write down your problem and question, but that is all for this meeting. Before you go though, I do want to make sure that you will receive at this meeting this STEM Wizard info sheet. It is super important that you fill out this info sheet so that the student leaders, Ms. Hepler and myself, can put all of your information into STEM Wizard, which is the online platform, so that way we can get a head start and you can get right into being involved in science fair. So please take this home, take this page home, and go over it with your parents and bring it back to the next meeting completely filled out. At the bottom, all of the ideas at the top, or all of the questions at the top, are just general questions, information that your parents and you can easily fill out. But at the very bottom, it says, in a few sentences, please describe your current project idea below. This is tentative and can still change. I want you to know we're not in the stage yet where your project is like final or anything, but please, whatever idea it is that you have, please list it at the bottom so that I can help you choose a category when we're creating these online accounts for you. And this can change again later, but that way you can also take the opportunity to discuss with your parents what you've been doing, what we've been talking about, and what it is you plan to test and study, and you can ask them questions. Many times our parents are our biggest helpers, and I'm sure they would love to hear about your project. I'm so glad that you all came to this meeting. I'm so glad to talk to you and be able to explain all of this. Please let me know again if you have any questions. And I hope that you guys have a wonderful day. Bye, guys. Have a wonderful meeting.